Hey everybody, welcome back to RC with Adam. My name is Adam. Welcome to the first ever 1 hour design challenge. So, what is a 1 hour design challenge? Well, it's where I'm going to limit myself to 1 hour to design something or spend on designing something. Because if you're like me, you know you can easily turn something that's like, oh, a 15-minute designing an idea into like hours and hours and hours. So today we have a design that's not from scratch. It's a fidget toy that I've designed, and I'm going to be doing the V2 version of. So this is cool. This is just kind of a concept that I just thought of in my mind because that's where I think of most of my concepts. And basically, we have two hemispheres connected. Hemisphere? Is that what it's called? A half sphere. I think it's a half sphere. And they're connected with a connector in the middle, and so they can rotate around each other, and then also each hemisphere can rotate as well. Can you see that okay? Okay, cool. And then they're locked together with a piece of filament. Now, there's some things that I want to change, and that's where the challenge is. So here we go. 60 minutes starting right now. Okay, that's not going to include 3D printing time. This is going to just include designing time, probably. I don't know. I make up the rules as I go. So, so there are a few things I want to change about this. And a great thing to do, what I suggest is whenever you are designing something, is to have a list of the things that you want to change or the changes that you're going to make for V2. So this was V1. Some of the things that weren't working well was like the filament, the holes that I designed in here for the filament to go through were not large enough. Actually, let me just show you this. That probably makes more sense. Here we go. So here we are in OnShape is what we're using for modeling right now. And you can see that we have this model here. The holes right here that run all the way through both hemispheres for the filament were not large enough because, you know, you need to make the hole a little bit larger when you're 3D printing it because of the basically the tolerances of the printer and all that. So it's going to end up a little smaller generally. So I had to drill those out to actually fit. So we're going to enlarge those a little bit. Let's go back to our list just to kind of show you some of the things that we're going to do here. We're going to decrease the sphere diameter because I feel like they're just a little bit too big. So the idea with this, I probably should have mentioned this. The reason why this is fun is you can kind of like roll it around in your hands, kind of like those like steel stress ball things, or maybe they're magnets. I'm not really sure. That's fun. You can also take it and like spin it like that, which that's fun too. But my hands are pretty large, and this like barely fits in my hand to be able to do that. So if you have smaller hands, if you're a kid, that's not gonna like work. They are really slippery because both of the hemispheres turn. So I'm not really gonna change that, but that's just kind of a funny thing. And then the connector here, I might make it closer together, but it definitely needs to be larger because you can kind of twist this, and if you twist it, you could break it. So I don't really want that to be twistable. Also, you'll notice how these kind of wobble back and forth. Hopefully you can see that. I don't like that. That's not how it was supposed to be. Also, that's partly because the filament was not totally straight. So that's a bunch of explaining there. So basically, we're going to decrease the sphere diameter, widen the middle connector, increase the filament hole diameter, add a tiny spacer maybe to reduce friction and reduce that noise. Decrease the connector length possibly, or we're going to try that out anyway. I might change that. And we're going to potentially add like a divot into the top here so that you can kind of grip it better, or at least smooth this out so that when that filament is melted in place, it doesn't get in the way. So it's like nice and smooth at the very least. So potentially it would take away a lot from the ball shape of it, but I don't know. That's what's so cool about 3D printing is you can just try whatever you want to try. All right, so let's get to it. So step one, we're going to get into our sketches here. Like I said, this has already been designed, so we're just going to be going into this and modifying it. I'm not going to explain a lot of what I'm doing exactly, but hopefully you'll kind of learn as we go. I'll try to narrate a little bit. All right, so actually I'm going to narrate a lot. I don't know what I'm saying, but basically this is not a tutorial, but it's more of like a come along for the ride. But I can't really help but narrate stuff because I talk to myself anyway. So 40 millimeters is the diameter of the hemisphere, and these are the two circles that I built this shape off of. So we're going to change that to, I think 35 would be good, and they are mirrored. I guess I think they're mirrored, something like that. All right, and excellent. So we've already decreased the diameter, which you'll notice that it makes more of the middle connector showing. So we also want to change the middle connector. You can see when I go over to Sketch, when I run the mouse over Sketch 2, that's the connector sketch. Let me hide everything else so that we just get that one sketch. Hide that sketch as well. I've used the circles from that previous sketch into this sketch, which actually, now that I think about it, I guess I could just use those, huh? Oh yeah, okay. All right, so let's do this. So let's take, oh, okay, that might screw everything up. This is the part that I'm not super great at with like CAD modeling, is like keeping everything so that it like lines up well and doesn't like, so that it's easy to make changes to things I've already done. All right, so let's take the 48 millimeters. So if we have 35 and 35, then we want 36 maybe between the pivot points. Oh, except that's not between the pivot points. That is between the ends. Ooh. So that's all right, let me see if we can, because what I want to do is I want to get the, okay, I'm going to press D to get the dimension. Okay, we're going to do L and then Q to make it a construction line for just for reference. And then I'm going to drag that to the other circle. Let me see if this will work now. So now we're going to do D. We're going to dimension that line. So 42 millimeters is what it was. So we had essentially a 2 millimeter distance between the circles. But now I really actually want like 30. So the diameters of those are 35. So let's make it 36. And that's not working. Probably because I have this dimension here. Can I delete that? 36. Can we do that? We can't do that. Let's see. Oh, okay. Is that something is locked? There we go. Okay, cool. Great. Oh man. All right. So let's see what that does when we show all of our parts here. So what that has done is, okay, basically not nothing, but let's see, the so that one's lined up. This one is not lined up. Is it because of the extrude? Well, I extruded that was based on that sketch 2. So I've changed sketch 2. So why hasn't that changed as well? Looks like we've got a conundrum on our hands. So sketch 1. All right, so these need to be lined up. These should be lined up. What's going on with sketch 1? Oh, okay. So I did change the diameter, did not change the distance between the two circles. Okay, my bad. Obviously, because I'm the only one doing this, so that was my bad. 36 is what we want. Boom, there we go. Okay, and then let's see what we're working with now. Let's show all the parts. Okay. Yeah. Okay, I'd almost want maybe less than a millimeter, but we'll just give ourselves a millimeter because we want this to actually work. instead of being like too close, because if it's too close, that's no fun at all. It's just like broken. It doesn't work at all. So we'll give ourselves that. So that is, so we've decreased the sphere diameter. We've, and we've decreased the connector length. And, okay, great. So now, I think I did that right. It's actually surprisingly hard to do this when I'm recording it and talking about it, because I'm trying to. I usually narrate out loud. That's not really strange, but making it make sense is that's the tricky part. So check this out. So let's just click. So we're in this extrude that I did to create the middle connector. So this is what the middle connector would look like now, right? So it would basically be a disc, and it's connected just like that. So I'm going to add fillets and stuff because we still don't want this really, really thin connection, even though it looks kind of cool that they're like barely connected, but that makes it way less durable. So theoretically, okay, wait, how could I? Okay, I'm not going to worry about trying to add teeny tiny little spacers right now because I don't know how I would do that at the moment, and I don't. We need to get this one out and give it a try first, because also I don't know how we would do the spacers without giving us that wobble again, and then it wouldn't be smooth. And then we're probably going to lubricate this with like a dry film lubricant, food safe dry film lubricant. All right, cool. So so we do have a gap, so we wouldn't have a perfect sphere, which we kind of should change. Why is that? Why do we have that gap? That's a good question. Let's take a look. So we've got a bit of a gap. Oh, okay. Well, we just basically need to increase that extrusion. We could do it different ways. We could do the. It's actually the sketch. It's the sketch. It's sketch one. Sketch one. So actually, for sketch one, we would. No, because that's 2.5. That is what that is. Did I do an offset? What did I do there? Because that would be a revolve. Oh. Okay. So you can see here, this might not matter. I'm not going to worry about it right now. You can see here, though, that we have this curve of the ball, and then here it's straight. It's not curved. That kind of bothers me deep down inside. I'm going to be honest with you. So potentially one way of fixing that, and also potentially causing other problems, is to get back our sketch one. And you see in this segment right here, it's curved. So what we would do is, we're not in the sketch, but we have our sketch showing. We're going to go up here to revolve, and then revolve this section on this axis. Shabwam. And now we have a solid body with the curve of the sphere. And can I do more than one? No, I better not, I guess. And then, of course, I guess I could mirror that to the other side or something, but anyway, for now, how would I do that? Oh yeah, that's not really a problem. I realized I could have just done this instead of doing the other sketch with like the hole, like the circle and the hole and stuff. It does help for the hole, but I don't know about that. So let me just take this whole, that part, right? So you see, because I did this part in the Z orientation, I guess, looking straight down. But now I kind of realize we don't, aside from the connector, we don't really need to do that. But I'm not going to go back and like change a bunch of stuff. What I'm just going to do is once again do a revolve on this side of the sketch, and then get our revolve axis, which is going to be that the axis of the circle there. And we're going to say, okay, cool, great. And then I'm going to take part 6 and part 7, which are those parts, and then Boolean, we're going to go to Boolean and connect those. So we're actually going to union part 5, 6, and 7. I don't really want to keep the tools. That's just going to be confusing. So don't keep the tools. And then, great. So now we have a single part here, which I realize now that connector needs to be larger. How did I do that last time? Actually, because if I have that, is it better that it's not larger? Maybe. Let's just leave it alone and see what happens. Yeah, okay. And then, so now, let's show everything. Boom, so there we go. So you'll notice in here, we don't have any tolerances, which is not really reality, but at the same time, these parts are just going to be stacked. That's the idea. All right, so just a couple more things here that I want to do. Let's hide everything again. The other major thing that we need to do is get into Sketch 2. We're going to go to View Normal to Sketch Plane so we can see it like flat. And then 2.1 is what I did for the whole. We're going to do like, because the filament is supposed to be 1.75 millimeters. But usually let's just be generous and do like 2.5. Yeah, that'll be better. Be on the safe side. Because again, as much as I do love to just try to go for a final version right out the gate. Is that actually 2.5? It's better to just kind of, do it incrementally. Okay. Is that 2.5? I guess it is. Doesn't look, well, it's not going to be much bigger. But anywho, also, what I want to do here is add in the sketch. Let's go ahead and do it in the sketch, I guess. So in the sketch, we would do a fillet from here to here. Oh, we can't do that. All right, maybe we can't do that. So that's fine. We'll just go with that. And then we're going to show all parts. Or no, we're not. Not all parts. Hide all of those except for part 5. And then I want to see if I can do a fillet. Also, we haven't actually changed anything with the hole sizes, so we got to keep that in mind. Darn it. So, okay, so I want to do a fillet like that, but I can't. All right, that's okay. I don't even need to do, it doesn't have to be a fillet shape. Before I forget, let's go ahead and hide everything. I'm going to go to Sketch 2. We're going to go to Extrude, which, actually, did I already extrude? Oh, okay, I already did do an extrude. Let's take that extrude so we don't have multiple extrudes. And we're going to, oh, here's something cool. Okay, so now I took that same sketch and I had the extrusion for the filament coming out of there. I'm actually going to just leave that alone. And then what I'm going to do is actually take that extrude. Maybe it does need to be bigger. Darn it. Okay, yeah, it does. So anyway, it needs to be taller. Let's just make it really tall. Okay, great. I think that's right. All right, and then we're going to take that extrusion, or really cutting away, removing filament, and dragging it down so that it will show up after all of the other parts that I've created. So now we have a nice hole running through everything. All right, cool. That's really great. So the next thing, we're going to go back to sketch 2. We are going to, I'm getting confused here. Let's say view normal to sketch plane so I can figure out what's going on. There we go. All right, so we're just going to add, and it's not a fillet, but we're going to add a 3-point arc. How far out do I want this to go? I mean, not super far out, but I don't know, maybe like, it should match up. Is it going to match up? I'm trying to take it straight across. Is that even? Oh, look, I can use that the little point. I can't show it, but right by the 36 number, I can see the center point of the arc, and I can line it up on that line. Kinda. That kind of works, right? And if I drag it enough, it should... let's just do it like that, and then let's press enter there, and then we're gonna get our concentric parameter thingy. Or dang it, not concentric. I'm bad there. Tangential. I'm gonna click on our curve, click on our circle, and then click on our curve, click on our circle, and then that way it's a nice smooth transition there. So that should be also very satisfying. In fact, now that I think about it, if we take a look at the spheres here, the other fun thing that's fun about this is to like kind of put it in your fingers and like kind of like you would with like a coin, and kind of dance it around in your fingers. But you see the gap here, that might make sense to just have the middle piece basically follow the curve of my finger. What we're going to do is to make sure that this is the same on this side, we can just use our little mirroring feature. So select the line to mirror. So we want the mirror line, which is going to be the center line. And then we want the entities to be mirrored, which is going to be like that. So is this going to be good? I don't know. That's why we're going to try it out and 3D print it. And, you know, it'll be great. So what I'm going to do is actually, I'm going to go to this extrude. No, I'm going to go, yeah. I'm going to go to this extrude and just include those little parts that I made there. Oh man, sometimes my vocabulary of this is not the most goodest. Anyway, and you can see it is a little shallow. I don't think we want that. Let's go back to that extrude. Uh-oh, where'd it go? Extrude. And it looks like, let's line it up on the side. So we can see here, we really could do probably like what, 3 millimeters? Wow, that's way too much. 2.5 millimeters? 2.4? Yeah, we could do something like that. We could do 2.4. I mean, we could do 2.5. Let's just do it, because again, we don't need these. We don't need to have tolerances built into these parts, because we're not going to be 3D printing them together. Okay, so that looks really good. Looks nice and good, nice and good. And I had some kind of idea about something. I have a hunch that it might be a problem that this middle sort of rotational part is the same size as the exterior of the circle or the sphere, but I could be wrong, so we'll just have to see about that. And then I was thinking about adding some ridges like on the outside as to reduce the friction theoretically, but I don't know about that. And then since this would be printing flat, I couldn't have it on both sides. It would just be on one side, and then it would just be weird. So probably not going to do that. We'll figure something else out. I mean, theoretically, I could do an internal bearing inside of here. So we're not relying on the filament to be the bearing. That's just one option. We could also add we could add a chamfer there, but I'm not gonna, because, you know, that's easy to get carried away with chamfers. You know what I'm saying? You know what I'm saying. All right, cool. So now we have this. This looks much more like an actual thing, I think. It looks more, much more cohesive, I think. So let's go back to our checklist here. We have widened the middle connector to sphere diameter. We've increased the filament diameter hole. We're not going to add tiny spacers. Yes. And finally, adding a chamfer / fillet, basically like a divot or a thing to the top. So let's play around with that real quick. So basically, the simplest way to do it would be to say, hey, we want probably a fillet. Let's see, on this top hole right there. Oh yeah, see, so it's nice and smooth. Obviously, if we want to get it nice and smooth, the smoothest, then we would need to adjust the layer height. Wow, look at that. Lolby. It looks like some sort of vortex, which is actually pretty cool. That's like nice and smooth. But would it actually be that smooth in real life? That is the question. And I'm not sure. And then, as you can see, we're taking away from the spherical shape. And do we want that? I don't know. Camera lady doesn't know either. There's no way to know. I guess I could do it on half of them. You know, just to see how I like it. In fact, let's do that. Let's just play around with it. Let's just, even though that's going to be a pain for doing it later, but whatever. Smooth fillet corners. What does that do? Oh, nothing. For this variable fillet. Smooth transition. No, I don't want to mess with that. So distance curvature. Oh, okay. That's probably a little bit more like it. It's a little bit hard to see with how this whole thing is. I don't know. We're just going to have to figure that one out. That is interesting, though. So 5.646. Let's just call it like 5. How about that? It's way easier to remember next time. So theoretically, oh, you know what though? Doesn't that make the hole much larger? I don't know, but that's fun to play around with. And then let's just say, yeah, sure, we want that. So this one, we could do a chamfer. So a chamfer is like a straight wall like that. So that's what a chamfer is. And we could do, let's kind of zoom out here a little bit, because it's very easy to get really into it and then think that you're dealing with really large areas or surfaces when you're not. It's like very, very small. So if we just take our handy dandy calipers and we kind of look at the filament, and when it's smushed down, it varies, you know, but it actually smushes out to like 2.8 in that case, 2.2. It could be larger, you know, it could be larger, it could be smaller. Obviously, you want it to be big enough so that it doesn't come apart. So at least, I mean, potentially 3 millimeters, but, you know, 2.5, right? 2.5 millimeters, which is actually the size of the hole, but it's actually going to be smaller when we actually 3D print it. So anyway, the point here is we don't want this to be too deep. And so I think 2 millimeters is the depth. So as far as the depth, like we could, I mean, 1 millimeter is very, very less deep, but in a sense of keeping it like a ball, we don't want a huge amount. We might not also want that to be 45 degrees. Maybe we want that to be, well, let's see, because if it's too deep, or if it's too shallow. Let's just go with 1 millimeter, 45 degrees. And then, so the other part of this that kind of takes time is exporting things and then seeing how they look in the slicer. So let's just say if we wanted to do that, yeah. So between these two, which is nicer? I don't know. let's do this. Let's so we're gonna take so this part. Oh wait, why are there two parts? What's going on? All right, we need to deselect the top, front, and right planes, because then we'll keep selecting that and that'll be annoying. So I don't know why that is a separate entity. Oh, okay. So this is what I don't like. So you see how when this is selected, you see how much it's widening and then it gets to the top. We don't really want that because that would have to be pretty darn, we'd have to melt that filament like quite a lot, which is an interesting concept actually. All right, here's another cool thing we can do. We can do a section view of this baby. Go to 90 degrees. All right, and then let's make that part visible again. Boom, there you go. And now you can see the difference there between a chamfer on the right, very simple, very small, versus a much smoother shape on the left. And of course, we're going to be building this up layer by layer with the 3D printing. So as far as the smoothness, it's actually going to feel less smooth the more gradual that curve is. So, at least theoretically, but that's a fun thing to see there. So let's turn that off for now. All right, so let's get this. So this guy and this guy are they? So that's part 2, part 3, part 4. All right, so that's part 4. So part 4. We're going to export, and for now we'll just call it part 4. Export. This one, part 1, we're going to export that as well. Export. Okay, now at this point I'm going to open Bamboo Studio, which is what I use for 3D printing stuff. I have Bamboo Studio up, and now I'm going to take those two parts that I exported from OnShape and drop them in here. There we go. So now we can, there's the other part. There we go. They were stacked on top of each other. Okay, so now we'll just slice it. These are going to be the standard Bamboo Lab settings, which I'm going to change for sure. And we can see that's layer height. We don't want that. Let's go to filament. No, let's go to line type. There we go. So now we can see what's going on here. Oh, okay. So I'm glad we did not go with just that. So it's a super simple shape. It's a half sphere. But the difference is right here, once we get to 12.2 millimeters or so, it really starts to widen out on the one that we did the fillet. So that's not what we want, because then we would have to have like a lot of filament to be able to squish, and then it's very likely it would slide through. So we don't want that. So we could potentially just decrease that fillet. However, if we look at the line heights, you can see that we're getting a lot of spaces between the layers right there on that one. Versus this one, it's pretty consistent, which I think that's actually going to feel better. It's probably going to be smoother as well. And there are some other things we could do with that as well. Obviously, we could increase the number of walls to make it just wall stair steps. That's probably what I would do for this. And we'd probably use the height modification tool, which is pretty super cool to be able to do that. That's one way of doing it. All right, so let's go back to OnShape. Go back to OnShape. We're gonna get rid of this fillet. I don't like the fillet. I'm not filling the fillet. I'm not filleting it. Then we're gonna go to this chamfer. The chamfer even, I'm not sure if I'm feeling the chamfer. It is really small though. We have to keep that in mind. That's probably gonna be quite small. So I'm just going to trust that that is the correct amount. I'm going to click on all of the holes on the hemispheres, and so that it will be the same both ways. Also, wouldn't it be cool to make like a Pokeball version of this? I think that would probably sell really well. And you could do other things too. One idea was to make one of them smaller and one of them bigger, and then you could have like the big one be yellow and the small one would be like blue and green, which is like the Earth, and the Earth could orbit the sun, or the sun could orbit the Earth. That could be pretty cool. Or you could also using like different filaments, you could make them look like eyeballs, which would be like kind of creepy. But you could do different eyeballs on each side. Or another popular one I just thought of, you could do like emojis, maybe like smiley faces, but have like different sides be different faces. That's all for now. That's all I can think of for now. So we're going to actually click the check mark. All right. And you see why this is a challenge for me to design something or redesign something within 1 hour. Oh boy, my editor is going to have a lot of fun with these videos. So I think that's it. I think we did everything. Okay, great. So now what we need to do is make sure that we actually want all these parts. So we have 1, 2, 3, 4. So it's 5. We have 5 parts, except here's what's cool. So the reason why I didn't want to make 2 different ones and stuff is because that's a pain. And so what's cool is I can actually just export one part, and then part number 1 and part number 5. I'm not going to export them together because I'm pretty sure then they'll be stuck together. So I'm going to go to my downloads and then just move those to the trash so I don't get confused. And then I'm going to click on the part, click export. I know it's like the same part, but I'm just doing it again. So for now, we'll just do that. I'm not going to bother naming it. And then part 5, export. There we go. And that is part 5 again. I'm just not going to bother naming it. And now that we have those parts, I'm going to go back to Bamboo Studio, or Bamboo Studio, as I like to call it. And then what we can do is, so now we're basically getting into the slicing phase, and we're going to grab these 2 parts, drag them in. Do you want to load these as a single? Blah, 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 blah. No, never do. And now we get to the part where I wish that I would just go ahead and make a profile instead of changing the Bamboo Lab profile every single time. So I will do that, and then I'll make that available for anybody who also wants to be as awesome as me. So we're going to take this one, and actually a little pro tip here, before I'm going to adjust the slicer settings and then copy and paste this one hemisphere. It looks like I have about 15 minutes left. We could probably do them both the same. Yeah. So layer height 0.2, that's fine. No, it's not fine. Actually, I take it back. So, maybe I'm getting a little crazy, right? But I'd like to maximize my filament. So for this flat surface, or the flat one right here, we don't need, it doesn't really have curves, vertical curves. So we're going to do like 0.26. I think it'll let me do that. We're going to do, so quality, I'm going to do outer wall of like 0.8, which is really, really thick, but we don't need it to, we don't need, actually, wait, do I want to do that? I could, yeah, I'll just do 1 outer wall. So I'm just going to do 1 outer wall instead of 2 outer walls. And then that also speeds up printing time. That's one of the things that it does the most. Top shell layers. So we do want it to be smooth, actually. So, but I'm going to say at least 3, and 3 on that one, and then I'm going to make that 0 so it doesn't. Yeah, so it changes it. Infill. We could do rectilinear, and we want it to be smooth. So we do want to have a good solid base on there. Let's just keep it 15 for now. I usually like to use rectilinear because you're going to get the most support area. It's not the strongest though. So the speed, that's a little spicy. The outer layers, 200 is a little spicy. Actually, you know what? That's so I'm going to be using 3D Fuel filament because it's the best filament in the world, and you're supposed to be able to print up to 250 with that, but we don't want complete, garbage quality, basically. Not that that would be necessarily, but I just don't see a need for it. Especially the top surface. Slow down your top surfaces. My goodness. So we're going to do like 30, which, yeah, is that going to take longer? Yes, it is. But we're going to have a smoother top surface, and that's really what is going to help probably with being able to get a nice smooth rotation. That's fine. Let's move on to this guy. All right, 0.2, that sounds good. Strength. Yeah, we can do 2 wall layers, fine. We'll be generous. Shell thickness, 0. I can't remember if the top shell thickness in millimeters. I'm pretty sure if you don't change that to 0, it will just do 1 millimeter, even if you change the top shell layers. I'm pretty sure. Top shell layers, 3. Bottom shell layers, 2, because we don't need a lot there. Again, infill, rectilinear. Yeah, we can do 15%. All right, let's see what that gets us. Kapow. And we are at this, and let's start from the bottom. So we probably could just do 2 for that one too. Probably should do 2. I'm not sure why it's alternating the layers. That's something that I don't understand, and I'm not sure about. It's rather strange. Yes, well, in any case, so we've got that going. Really, for the most part, that infill is not necessary for most of this because it's stacking straight up. So we could really probably reduce that, and maybe we will. I definitely will to optimize this thing. So towards the top, what we want to do is actually decrease the layer height, theoretically. Not sure why I said that so slowly. And let's just go back here, and then if it seems like I'm nerding out on this and getting a little crazy, it's because I am. Don't judge me. And because this is fun for me. And if you're still watching, it's probably fun for you too. So bottom layers, because the bottom layers are already going to be smooth and flat because they're on the you don't have to support the bottom layers because they're already on the bottom of the build plate. Just for funsies, let's go to layer heights, and we'll say adaptive. And you see how it does. It's gonna really smooth that out, which I like. I think I like that. Let's smooth it out. Well, what do we got there? 4.4. Yeah, smooth out. Just low. Yeah, just so it's not too crazy. Cool. So most of it is large layers. Yeah, we'll give that a try. That should be pretty reasonable. And then also, it's just going to bother me if I don't change the amount of infill because we don't need 15%. We can do 10%. And because, hey, it all adds up. You know what I'm saying? It all adds up. Especially if you use good quality filament and it costs more, which is why I actually use the 3D Fuel refuel filament when I'm doing prototyping. Anyway, that looks pretty well supported, but again, this is not the final version. Up here at the top, we'll have to see. We'll just have to see about that. All right, I need to stop talking and stop slicing and actually start printing. So copy, paste, paste, paste. And I think that's all we need really. And then go ahead and arrange that, sure, so it's nice and pretty. Let's do this on the A1. We're going to do this on the A1. I have the A1 and the X1 carbon hooked up right now. Let's change this to 240C 3D fuel. Okay, and that should be it. We got textured build plate. We got to make sure our device, got to change it to the A1. Slice the plate again. Okay, and so about 41 minutes. How cool is that? That in 41 minutes, we can, plus all the time that I spent, we can take a design and turn it into like actual physical thing that we can like see if it works or not. Like that's amazing. So right here, we have the A1. You can look at the A1 here. The filament we're going to use is 3D Fuel Tough Pro PLA Plus Refuel, which is where they basically recycle their own fuel filament. So they call it Refuel, which is pretty cool. And I got this all messed up here. There we go. All right, so we're going to send that over, and I'm going to click Print Plate and send it. Should take about 17 grams. Good celebratory knuckle crack. And we're just we'll get that baby going. So we'll check in on it when it's actually printing, I guess. And then we'll check in on the final amount. Looks like I have about 7 minutes left. I don't know, I wasn't really reading it. More than 5. That's kind of how I tell time. Like more than 5, less than 10. What is that? I don't know. So there we go. So she'll just take it away from there. Or he, I don't really know. It's a 3D printer. Didn't really think that through. In any case, we'll be right back. Like magic, it's done. Here it is. Give it a little bend. Pop right off. There we go. Get that off of there. Let's take it over to the bench. Slide them off. And take this plate back. Put it back. And we are ready for the next print. All right, so basically, here's what we're going to do. So first of all, here's the original. So this was our first test here. You can see there's this gap. And then you can see each of these hemispheres spin independently of each other, which is cool. So I think I might call this the Slippy sphere. I don't know. Anyway, now we have a piece of filament. This is actually PCTG, but that's fine. You'll notice it's curved, which is not ideal. So really, I might need to straighten this potentially. But that's why you see how the two halves are like not straight up and down, like they're not tight and just evenly spaced. And that's because of the curvature of the filament. Also because we just have this very thin connecting bar. So now we have this nice thick connecting bar, and should be much more durable, much more durable. And it's kind of cool because this filament's kind of translucent, so you can kind of see through it a little bit. And then we have our spheres. That feels pretty good. Feels pretty nice and smooth. Yeah, quite nice actually. And you can see the I'm gonna cut the end off of one of these guys. You can see, let's see, will it fit through the hole? Oh, like a glove. Like a glove. And then you can see that the chamfer that we put in the top is, let's see, can that focus on there? Is not very large at all, but I think it'll actually be just right. So really all we're going to do is take a piece of filament and cut it off. We're going to take one end, and of course all these are identical, these halves, and very smooth actually. So this was printed with the textured PEI plate. So it is textured, but when they rub together, they're very, very smooth. That's super smooth. Less smooth. Oof. That's pretty darn rough, actually, to be honest. That's not great. So this top texture, maybe we would want to do ironing, perhaps. Potentially, we'd want to iron. What I'm going to go ahead and do is get this stuff right here. I love this stuff. This is Super Lube dry film lubricant, and we're just going to on the top side here. I'm just going to give it a little spray. Get some of that on there. Let it dry. And once it dries, is when it's actually very slippery. So, oh wow, it's quite a difference. So, let's see, let's get this guy. So, I don't know if you can hear that. Very, very big difference. So, what I'm going to go ahead and do is just apply some of this to this dude. Both sides. This stuff is really great for lubricating 3D prints because it is it dries. I was gonna say it dries dry. That doesn't make any sense. But it dries and then it's still a lubricant. It really takes the friction away, and it doesn't collect dust or leak out and stuff like that. So we'll take this guy on one end. So we'll get our lighter here. We'll go ahead and smush it. Oops. I guess a flat surface would be better, huh? I'll just kind of smush it down like that. So it's really flattened out a lot. I think it's kind of focusing. Yeah. And let it dry. Let's put our lubricant away before we set it on fire. And so, like I said, we still have this bow in, kind of, this bow shape to the filament. We'll see if that's a problem. All right, so we'll take 1/2, slide it through, and so you see it sticks up a bit. We don't really want that, so we could just kind of melt it a little bit more, and then take our lighter and just kind of, I guess ideally we'd have some sort of conical shape, but the idea is to make it so it's flush to fit in that little spot right there. All right, then we'll take our centerpiece or our middle connector, attach the second side. There we go. And I'm going to push on here with my finger, pushing the filament up, and then we're going to snip off I'm going to move that so you can see the background. Snip off almost all of it, like quite a lot. We're just going to leave a little bit sticking up. Melt it. Now, the tricky part is we're melting the ball as well, but maybe we'll figure something out eventually. It's actually kind of, because it's kind of in there, it's actually a little tricky. It's a little tricky to make sure I'm squishing the filament end. All right, so we'll probably have to come up with a better way of doing that. Gonna make sure it's nice and dry, or cool, not dry. Nice and cool. We've got a little bit of play. I guess we don't want it super tight. So, oh, it's kind of terrible, actually. Darn it. That was kind of what I suspected. What I suspected was that the edges of the print might cause more friction. Ugh. All right, so like around the edge here, it's quite rough, relatively speaking. So there's quite a lot of friction. You can see it doesn't spin like here, like it. The old version, they move quite freely. This version, they do not. Also, they're in line with the, or how do I put that? There's less of a gap, which I guess is part of the problem, right? Because there's actually more friction because of that, which is why I was talking about possibly doing little spacers on here. Okay, one idea is what I'll do is I'll just get a little bit of this 2000 grit sandpaper, and I'm just going to sand it a little bit. Let's give it a little sandy sand. That kind of helped. That kind of helped. Actually, that side's kind of rough too. Sand it a little bit on that side as well. And then we can at least tell the difference between each side. Basically. I'm trying to hit those edges too. super smooth. Better. It is definitely much better. Go ahead and hit this with the super lube again. May as well get some on those other pieces, huh? All right, let's try this again. Get a piece of filament here. It's funny, this particular color looks a whole lot like weed whacker string. That's fine. Okay, so back up a little bit, get a little more space. There we go. All right, so we'll do the same thing with this guy and try not to burn my fingers. So this is kind of the tricky part, right? Because we're trying to cut it really close, but also leave enough so that we can melt it, but it needs to be melted down lower. So theoretically, this whole idea is not the greatest. I guess probably something like a soldering iron or something that had like a hot tip that I could just press on there and melt it. That'd probably be better, but let's make sure that's cool. All right, and here we go. Here's kind of our final product. It does fit my fingers much better, I think. Like, I think this is like a fun thing to do with it. It is not as slippery. You can still kind of do that. So basically, having some upsides. Some upsides are that the balls don't wobble around as much. Each sphere is more solid, and it looks more solid. So it kind of has a nicer look to it. It definitely kind of looks like a pair of eyeballs, doesn't it? It looks like Wallace's eyeballs from Wallace and Gromit. Not the same color. And so that's cool. I like that it's stronger. It's very hard to rotate. But since I made the connecting piece, the diameter the same as each sphere, or to complete the sphere basically, and because there's some wiggle room in the tolerances of where the filament is connecting, the hole that's the filament is going through, it's causing it to be able to, when the two spheres or semispheres are pushed, we can see that, maybe you can't, it's hard to tell, but you can see that basically the middle connector can sometimes push out and be protruding from there. And that's not good, because then it catches on your fingers and increases the friction. So basically, what I would probably do next is bring it in a couple millimeters, make the diameter a couple millimeters smaller, at least for that. The other problem that we encounter is there's increased friction due to surface area of the connecting piece, and which again, that was kind of anticipated. You can kind of expect that. I'd say the tolerances here, because you can see from the smallest, it's probably like 0.5 millimeter to like probably like 2 millimeters, 2.5 millimeters. That's how much wiggle room there is due to the filament in the hole there, in the pass-through hole. So yeah, and you can't like back out a little bit. You can't do the spinny thing, so that's lame. Like, that's cool. That's super cool. That's much better. This is not. They're like rough. The only thing is, like, they do kind of fit better between fingers, which is kind of cool. Looks like oh, that's loud. They're both still loud, but yeah, it's really not very slippery. So here's the thing. I think that probably in the long run, I don't want to do the filament connection thing. It's kind of, it's neat. It works, but because the filament already has this like bow to it, it's going to cause alignment issues. It's not great. What I need to do is come up with some sort of a connector piece that can somehow connect both of them both of the spheres, but also connect the middle connector, and then being able to make it so that basically the alignment is better and they're not wobbling around, but we have less friction, we have less surface area. So I'd like to thank you for joining me on this 1 hour design challenge. It has been an interesting time. It kind of ended on a little bit of a not great note because we didn't actually improve anything. We kind of more like figured out some things that needed to be changed and then I thought would work and didn't work, and that is how it goes sometimes. So maybe we'll revisit this on the next 1 hour design challenge. Thanks for watching. Now, I challenge you to challenge yourself to try this challenge and challenge something. Challenge, challenge, challenge. I don't know where I was going to go with that, but thanks for watching. Go out there and design something, 3D print something, and I'll see you again very soon.